Hello. Hello. Good. So, seems that everything is in order. This is. Hello. Good. So, wait a minute. Seems that everything is in order. This is philosophy of game design. Um, it's good for the speaker, I guess, to introduce themselves. So, I'm Ethan Hansen, essentially. Um, I've been thinking about game design for a long time, but only in the past year or two have I began to uh, apply my thoughts into actual projects. So right now I am working on a board game, which is kind of in a prototype stage, and I'm working on a a computer game, but that development is much slower because still developing my technical skills of programming. So the purpose of this talk is essentially kind of just to have a more of a discussion. This is kind of like a developer log in a way. It's a way of showing where I'm at in terms of my thought process, organizing my thoughts, and um, you know, trying to ultimately find the best way to think about game design. It's a process, you know. So in no way is this talk meant to be on. It's not really an educational talk. It's more of a talk about a beginner game designer and my developing philosophy and methodology. It's yet to be tested. It's I want to make a couple games and find out if this thought process works. But I think in some ways I am onto something, and so I wanted to share that. And so yeah, we'll just get right into it. So philosophy of game design. So there are a lot of big questions in game design. Um, like in any creative field, you have a lot of questions that you need to answer, and some are better to be answered up front first. So that is what I'm going to do. I'm going to try to answer some of the big questions, and keep in mind this is just my perspective, and it's subject to change, and that's kind of what philosophy is about, right? It's about trying to find some perspective on our perceptions, on our what we see as reality. So yeah, let's go ahead. So we use the word play a lot with games. Uh, Typically, and you're gonna notice this is gonna be a theme throughout the presentation, is that I think one of the main problems we have in game design is we are typically using terms and words that have very loose definitions, that have no real consensus of a definition, and It makes them interesting to talk about philosophically, but in terms of actually constructing arguments about game design, if you're using words that have very loose definitions, then I think that's weakening our arguments and our conversations. So my definition goes like this: play means control. To play with a thing means to have control over the thing. So just some kind of like little examples here. We'll say, "Oh, I play basketball." Like, let's break down what that term really, like, what that actually means. I play basketball. I have some sort of a control over, you know, this game, this activity. I've been playing this game. So if you break it down, you could think of it as I've been controlling this game. I've been doing this thing where I have control. Or you could, or in a more social setting, somebody could say, somebody's playing with you. They're messing with you. They're playing with you. They have control over you, some sort of agency over you. And yeah, so that's my perspective on that word. Next one is a big one as well. Like, we use the term game. Well, what is a game? So I actually have two definitions, which just goes to show this is all just a work in progress. First definition I was thinking about was that a game could be considered a set of rules, and it requires an explicit goal to be a game. And you'll see more when we get into the other types of games, why that's important, that it requires an explicit goal. Second definition is a set of systems. And we'll get more into this later as well, with framing the world itself as a set of systems, a patchwork of systems. Using systems theory to frame everything that we see is going to be important later on. So examples of an explicit goal could be score more points than the other team. That explicit goal shows up a lot in physical athletic games, basketball, football. Find a hidden item, that could be like, I don't know, like a puzzle game or something, but it's anything explicit that's told to in some explicit way to the player. Hold up. Okay. So then what is a toy? We say, the reason this is important is because often, connecting it back to the other thing, we say we play with toys. We're playing with a toy. So it's something we play with, right? So the definition that I came up with is that it's any activity that does not have an explicit goal, or like an object or activity without an explicit goal. And this is an important distinction because, when we're trying to create terminology, we have to have hard definitions. So, what makes a toy engaging for people to play with, to engage with, to play with, to have control over, is that with a toy you can give yourself any goal you want. It's a sandbox. It's a what's the word? It's a sandbox type thing. It's a malleable game. You can give yourself any goal with it that you want. So next thing we're going to go into this philosophy is we're going to talk about goals of game design, common goals that are going to be there across all of our projects. And once again, this is just my perspective. This is not dogma. This is not. I'm not suggesting that this is reality. I'm just suggesting that it's important to have some sort of perspective and way that you're framing and going about your design. So let's talk about goals. So they come in a hierarchy, right? There's highest level game design goals that are going to be across every game that we design. So that would be to manipulate the human mind. And manipulate is a negative word. You could use a word like influence. That would have more of a positive connotation, but the point still stands is that we're trying to take the player from the state that they're currently in to the state that we want them to be in. And that's going to require manipulating the human mind. So below that we have our mid-level goals, right? So these are more plentiful and more specific. So inducing emotion has always been important. That's a very common goal. A lot of games have that goal of inducing emotion. And as well, we have on the left there, we have satisfying fundamental needs. So we'll get into this later, but fundamental needs is essentially a theory of to explain behavior and what we like. I'll get more to that later. Here are other two ones. Take a mind to a fantasy, and this is something that I could get into a lot more detail about, but I'll just give a short kind of overview. A fantasy is sort of a fictional reality. It's anything that's a fictional reality. It's an imaginary scenario. And that's essentially what a fantasy is. It's an imaginary scenario, and we can put a player into that imaginary scenario. We can immerse them into it. The other one is communicating a narrative. So you can use the game to communicate a narrative, interactively, non-interactively, whatever. But that is a mid-level goal. So low-level goals. These are very specific, and very plentiful. Just to preface, these goals are not, you don't have all these goals for every game. These are essentially the goals that you're able to pick and choose from when you're starting the design of a game. So based on Maslow's psychologist, based on his theory of need, there are a couple of needs here. So just to give a list of every one that we could choose to satisfy. It's in a hierarchy, so self-actualization, we have a need for morality, creativity, and problem solving. Self-esteem, we have a need to have achievement, to respect ourselves, and to get respect from others. Love and belonging, we have a need for friendship, we have a need for family and romance. Safety needs, so we have a need for being not only healthy, but knowing that we will be healthy in the future, right? So we have a security of health, for resources in the family. And then the lowest level, we have physical needs, so breathing, food, water, sleep, sex, and excretion. So, these become our goals. If we want to appeal to people, then we need to understand that this is what they desire. And this is, of course, a theory, but it's a widely accepted theory, and so I choose for this philosophy to make my decisions based off of it, you know what I mean? So, human emotion, there's too many to list, you know what I mean? There's a couple of basic ones, but here I just have the theory, right? So, the theory of emotion. Emotions are biological states. Different states are different neurophysical changes. So, remember, everything psychological is also biological. So, there's no certainly scientific consensus. This is a very much work in progress. Part of this philosophy is my perspective on emotion, and what it really is, and how many there are. Last thing here is that understanding people is essential. I feel as a game designer, you gotta understand people as much as you can. Proper study of mankind is the science of design. Herbert A. Simon. So, there's a science of design, there's art of design. So, going back to what we were saying before, what do people desire to have? Fundamental human needs. Why does a person think or act the way they do? When a person has an unmet need, they initiate new behavior in the pursuit of satisfying that need. Our motivation or our desire translates into our behavior, and this is the core concept of motivation. What actions do people take to get what they desire? This is very much a work in progress as well as the ideas of human behavior. So, human behavior refers to actions people take in order to pursue the satisfaction of their fundamental needs, their desires. My current perspective on why people enjoy different things is genetic variation, and why people feel differently in the same scenario. Well, you could think of it as personality and life experience affects these things. So that is the philosophy of game design currently. It's a work in progress, and it's the current kind of frame mental model through which I'm making my game design decisions. So that's that. Other half of this presentation is going to be about the methodology of game design. So a methodology, I should look it up real quick, give you a real definition. Wait a minute. Oh shit. Hold on. Okay. Methodology is a contextual framework for research, a coherent and logical scheme based on views, values that guide the choices that researchers make. So, a system of methods used in a particular area of study or activity. So, the game design methodology that I'm about to speak on, keep that definition in mind. Let me check the chat real quick. Looks like we have, I believe, I'm new to all of this, but I believe we have no chat. So, no new messages at least. So yeah, we're moving on to the game design methodology now. So, put it in present. So, as I was talking about before with systems theory, I think it's very, very important to understand systems theory on more than the surface level. I mean, in games, we're always talking about systems, right? We're always referring to things as systems and contextualizing game designs as systems. So why not go fully into that and embrace systems theory, an actual scientific study, you know what I mean? So essentially, think of the entire world as being just a patchwork of systems, and it can reframe how you think about things in, I think, a useful way. So, common system components. We have a goal. The goal is a target that. Well, first let's talk about input, throughput, and output. That's really the core of the systems theory. Is that a system has an input, which is information, which is processed by the system, and then it has a throughput. So you give the system information, it processes the information, and then you finally have an output. That's the end product of the system's process. So you could think of processes as elements that convert inputs to outputs. So, all this might not seem very related to game design, but if you want to frame game design in a way where you can think of everything as inputs, throughputs, and outputs and systems, then that's one way to do it. So system types. We have static systems, so not susceptible to change. I'm trying to think of some examples of what a static system could be. Something that's not susceptible to change would be like a not really sure. Maybe like a table or something, like a desk. It doesn't really change, but it is a set of interrelated parts, right? So it's like a system. A dynamic system, the other type, it's ever changing and adaptable. So to think of an example, I could think of like maybe like a door or something could be a dynamic system because it could be in two different states. And also kind of related to these two is the closed system, which has fixed elements and relationships, and the open system, which is interactive and flexible. And that's really what games are made out of, right? Dynamic, open systems. They're all about interacting and change and making a change into some environment. So yeah, the goal, once again, where the system has some goal, the desired output is how we could consider the goal. So chapter 2 of the methodology. This is essentially the core of the entire methodology. This is where um, this is our most useful tool. It's versatile, uh, designing problems to solve and decisions to make. And this chapter, I mean, essentially, you know, Sid Meier, and Will Wright, all the great designers, Doug Church. It's like this is the through line. Like through all the research that I've done, all the studying that I've done of the craft of game design, it's like if an interaction at its heart is a decision, right? An interaction, you can either choose to interact or not interact. So essentially, the core of our medium interaction is also could be thought of as decisions. The core of interactivity is decisions. So let's go fully into that and say that designing problems to solve for the player and decisions to make for the player is like such a useful tool. It's not even funny. Um, a useful tool in terms of accomplishing our goals. So, just a little more detail. Why is it such a versatile tool? Well, it can put a person into a fantasy, as we were talking about before. Fantasy is a imagined scenario. It's an imaginary scenario. So, every game in its heart could be thought of as a fantasy. I mean, even a physical game like football or basketball, the scenario in which the players are put in is imaginary. There's no actual score system in reality. There's no point system in reality. That's all an abstract, imaginary thing. Other types of fantasies, you think about classic games like, role-playing games and action games. They put the player into this imaginary scenario where you're this badass soldier, or you're like a badass warrior, or maybe you're actually weak. If you think about Dark Souls, the fantasy of that game is actually that you're completely outmatched and that you're super weak compared to the enemies you fight, and so yeah. Um, Problems and decisions can induce a person with a specific emotion. So, through the process of solving the problems that the player has and making decisions, the through that process of decision making, the person is going to feel emotion, and so we can target that. Problems and decisions can also communicate a narrative, and this is super interesting if you think about interactive narrative. Um, Essentially, interactive narrative is telling a story through interactions, right? So through the interactions, through the decisions they're making and the problems they're solving, we're communicating a narrative, and we can target that as well. Um, Having problems to solve and decisions to make is also a great way of fulfilling fundamental needs, as we were talking about in our philosophy. So, if you want, for example, if you want to fulfill a need for, let's say, achievement. That's one of the best things that a game can do. That's one of the easiest things for a game to do is fulfill that sense of achievement, because you give a person a goal, and through the process of solving problems and making decisions, they achieve that goal, and they satisfy that need for achievement. So that's something we can also target. So this is my current kind of theory on problems. How do we solve problems? What's happening in our brain? What's happening with the neurons in our brain? I've divided it into 4 phases. So once again, this is just a theory. This is all subject to change, and this is all just a discussion, right? So first phase, we analyze the information we're given. Right? We perceive the stimuli given to us. Second phase, we compile a list of all the possible choices. So a lot of the times in games, you'll have wide possibility spaces. You could have hundreds of possible decisions that you could make, and that might seem like it would be too complex. But the thing is that a player's brain, what it's going to do is that it's going to take that list of 100 possible choices that the game could account for, and it's going to quickly narrow it down to the most valuable choices. So you can have 100 different moves that you could do in a game, but you're going to break down that huge move list into about like 10 or 5 moves. You know what I mean? Some small list of choices out of that possibility space that are the most valuable. Then once you have that small list, you're going to weigh the pros and cons of each choice in that list. So this can happen really quickly. It can happen. You could take a whole minute to weigh the pros and cons. It could be almost like a quick unconscious decision. And then the fourth phase, we decide upon a choice. So that is the current theory there. For decisions, I have a definition here. So a decision is a conclusion reached after consideration. Each decision should be an informed guess if the goal is to satisfy fundamental needs. Remember, this is method with the methodology. Everything's related to a goal, right? So you have a goal, and that's going to determine if you're doing something correct or not. The goal is to accomplish the goal. Ironically, so if the goal is to make the player unhappy, then not satisfying fundamental needs is going to be a correct way of doing that. So that's why methods are never. There's never one. You have goals and you have methods to achieve them, essentially. So decision types. We have trade-off. We have risk versus reward. There's other types but this is what all I thought of right now, and this is based also on Sid Meier's decision types. So trade-off. You trade off one thing for another thing. You have to sacrifice something to get something. Risk versus reward. So more risk you take, more reward you get. Also decision parameters. So if you want to understand the makeup of decisions and how to kind of how to kind of analyze each game and think about what are the decision types that the designers implemented into this game systems. So there are simple ones, there are complex ones, there are short-term ones, mid-term ones, long-term ones. And also another parameter is the hypothesizing time. How long is the player given to consider their intention, their decision? If you think about chess, you essentially have infinite hypothesizing time. You essentially have an infinite amount of time to sit there and consider your intention. If you think about a game like Devil May Cry, you have very short hypothesizing time. Yes, you could take a lot of time to consider your intention, your decision, but the game pressures you with negative consequences. If you don't make decisions quickly in Devil May Cry, you're going to get hit with a negative consequence. You're going to lose health. You're going to get killed. You're going to lose progress. So those are kind of the current parameters that I've thought of for decisions. And also, you can give multiple goals to achieve, right? So you can give a short-term goal, medium-term goal. You can have multiple goals that the player is pursuing at once. Also, if you're trying to satisfy needs, each choice having clear feedback is also important for that. So the feedback is consistent, it's clear. Feedback is the information that results from a decision. It's the output of an input into a system. Learning, what would I do next time? These are all kind of things that are, kind of being worked out and kind of developed in my methodology more and more. But I do believe that learning and discovery is one of our fundamental needs. I think that everybody does have an innate need for learning. Despite a lot of backlash for the current education system, I don't take that as a sign that people don't love to learn. So yeah. Intention, I mean, this is essentially going off the back of Steve Lee from Arcane Studios and his talk about intention. And this is related to problems and decisions making. So intention is essentially the mental state that you're aiming for when you're giving the player problems to solve and decisions to make. It's a mental state that represents a constant commitment to carrying out an informed decision or informed decisions for the future. So facilitating this state, you can present the person with a goal, present the person with information that is clear, consistent, and manageable, present the person with choices, ensure people are responsible for any consequence given to them, and ensure people understand why any consequence has been given to them. So this also really goes off the back of Doug Church and his talk on his article on abstract design tools, where he defined responsible consequence and perceivable consequence as game design tools. So part 3, the interaction loop. This is very important to understand, in my opinion. This is, even outside of games, this is happening. The interaction loop it's just a term that the word that I ascribed to this phenomenon, but you can give it any name you want. I call it the interaction loop. So it's a loop that repeats over and over for a person no matter what they're doing. So yeah, while conscious at least. If you're asleep, you're not going through this loop. At least, I don't think. And each different game design is essentially just tweaking what's happening in each phase of this loop. So by tweaking this loop, we're making new designs, we're accomplishing new goals. So here's the loop. Now you see here at the top I had 0, because that's kind of the preface. This is kind of the preface that you need to spawn this loop. You need to present the person with a situation and a clear goal, or at least information. So the first phase of the loop is that we gather information, then we hypothesize about what options do I have to choose from, then we execute. How do I execute the choices that I decided upon? Gathering feedback, what are the consequences, and then the loop repeats. So I mean, this is kind of like a crappy way of explaining it. There's a YouTube video by Extra Credits about this topic. And I wanted to show maybe a couple snippets of it. I think it's this one.
Hey everyone, if you have a quick second after...
Yeah.
It's universal, applying just as well to Tetris. There's a subconscious process we all go through every time we encounter a challenge in a game. It's universal, applying just as well to Tetris as it does Sekiro. And if at any stage things start to break down, a game goes from feeling great to feeling terrible. So, what are the steps we always go through? Step 1, define your objective. I need to get through this hallway. Step 2, gather information. Okay, there's an enemy there, and there. Step 3, form a hypothesis on how to achieve your goal. If I run this way, I should be able to get through. Step 4, test your hypothesis. All right, here goes nothing. Step 5, observe results. And I died. Step 6, interpret data. I guess that wasn't the way to get through. And step 7, return to step 3. All right, time to press continue. Now a quick note here, you only go back to step 3 if you failed. If you were successful, you go back to step 1 for the next challenge. In some games, this process is continuous, while in others, it's uncontinuous. And generally speaking, the more continuous this process is, the more strategic or puzzly we consider a game to be. But let's look at this step by step.
Okay, so that's essentially another way of thinking about that, right? So, there you go. So that's what I'm referring to with the interaction loop. It's very important to consider because whether you are thinking about it or not, this loop is happening in your game. It's even happening when we're not playing games. It's just any goal we have, this is how we kind of go through it in our brain. That's the current theory. So where to start with designing problems and decisions. You're saying, oh, well, you're telling me to create problems and for the player to solve and decisions for the player to make. Well, what the hell kind of problems and decisions should I make, One way of thinking about this is that quantify what the game is about, then set up decisions tied directly to what the game is about. Yeah, that's essentially it. I mean, it gets more complex than that, but on a high level, to choose what problems and decisions to make for your player, just say what the game is about and then set up decisions tied to that. Yeah, wait a minute. I'm gonna show you guys one of my current game design documents. I'm gonna show you an example of this. It's somewhere in here. There we go. So this is kind of one of the methods in which I've decided to, implement. You figure out what the game is about, and then you make this kind of problem and decision matrix. What is the game about? What is the fantasy that you're putting the player into? And then what are the problems and decisions that would be related to or involved in this fantasy if it were to be true? So you can see here I have a list. We have the problems involved in this fantasy, and then we have the decisions related to those problems. So if you have these problems, what decisions would you be making to accomplish them or to pursue those goals? And this is a good way to kind of really get a grasp on if this fantasy, to put this player in the fantasy, you can do it with problems and decisions. Well, what would the problems and decisions be in that fantasy? And this is a way to kind of get that. And through this matrix, through this idea here, we can go ahead and build our design, the actual systems. And you can see here, I do like a flowchart kind of system, and the way that I do documentation is kind of related to the way that I think about game design as components and tools, techniques, which in a second here. That's going to be the final part of this bit. So building a standardized game design language. I've always thought that game design has been, the way that we discuss it has been flawed, and that we need a standardized language. And this is something that Doug Church also talked about in his article about abstract design tools, is that, and one of the problems is that we have a lot of these terminologies that we use have very loose definitions. I don't, and don't get me wrong, the problem isn't that people have different ideas on what these words mean. The problem is that when we're discussing with each other and creating arguments about game design, we have to agree on the definitions of the terms we're using, or else we're not going to understand each other. So, first part, game design techniques and tools. These are reusable game design techniques and tools. So I just have a big list here. I'll just go through some of the important ones, but the interaction loop, like we talked about before, is a tool that we can use. Intention that we talked about before, that's a tool. Perceivable consequence, responsible consequence, those are two tools coined by Doug Church. And Jug Church was the designer of Thief, I believe. Well, one of the designers on Thief. He worked at Looking Glass on Thief and Deus Ex and stuff with Warren Spector. Um, so yeah, narrative is also a tool we can use, which is narrative thread. It can be driven by the players or the designer. Growth is a tool. Mutation is a tool that I coined the term mutation. Essentially, mutation is whenever we create a change to the rules and or game world. Um, so you kind of have the blueprint for your game. You have the game in its most fundamental foundation, and then you mutate that foundation to create new content. So you have your foundation for the game, you have your core systems, and then you create a mutation to create new content, like levels or missions, create changes to the rules. Like what you make a change to the goal, or you make a change to the game world, or you you know make a change to the you know things available to the player. Um, Other ones is execution and logical challenge. So we talk about challenge in games a lot, and my idea was to split it into two categories. So we have execution challenges, which are challenges based on the execution of a already decided upon plan. Um, so you think about something like Dance Dance Revolution or maybe Sekiro. The plans are pretty simple and they're already decided upon, right? You're told exactly what to do, but actually executing it is physically difficult. Um, and so yeah, so some games are execution challenges, and on the other side of the coin we have logical challenges. And these are going to be games that have create challenge based on challenging you to create effective plans based on the information you're given. So this easy example of this is chess, right? Executing your plans in chess is very, very easy. I mean, you just move the pieces. There's almost no way to fail. Um, but actually creating a plan about how you're going to move the pieces is what is challenging. So those are logical challenges, and games can have mixtures of execution challenge and logic challenge. Um, Player character connection is something I haven't really heard anybody talk about, but I think it is interesting to think about. And it's the connection between the physical player playing the game and the digital character they control. And if there is a player that controls a character, this will exist, so be aware of it. Essentially, it's a big topic, but, what's the connection between the player playing and the character that they're controlling? As you think about The Last of Us, and you play as a character, maybe you're playing as Joel, right? You're playing as Joel, the main character, and you are in control of him, right? But you are not Joel. Joel is a independent character from the player. So you can only choose between the decisions that Joel would make. Whereas in a game like Dark Souls or something, the player character connection is more like you are the character, right? The player and the character are kind of connected. They are not independent from each other. It's a blank slate for you to fill in with yourself. Okay, so finally we have game design components, and this is one of the biggest parts of my methodology, and I think it's a pretty good idea, but once again, these are all subject to change, and this is all being tested by the projects I'm doing and seeing if it actually is effective. So you can see the kind of visual analogy I have here of a floor, just a bunch of blocks all over the floor, disorganized, not in any sort of pattern or any way. And then on the left we have that same blocks of same components that were all disorganized and on the floor, organized into something new that we can call a new thing. So these are reusable game design building blocks. These are the things, the building blocks and components that I believe are in all the possible game design components that could be in any game. Compile a list of them, and we just reuse them in different contexts. One important concept is that the different design components have different levels of abstraction. Some of them are highly abstract, and some of them are not that abstract. So if we go back to my design document here, you can see in the center we have this huge component here, system, right? This is a very high level abstract component, because what is this component is actually just a shorthand way of talking about all of these lower level abstract components. So something like the system loops would be like mid-level abstract. How abstract a component is based on how much information does that component refer to. So very low level abstract components are going to be are going to be the ones that don't hide much information, that are very close to being the more detailed components. I don't know. I'm not explaining it very well, but once again, this will all be more refined and more through testing. You know what I mean? So yeah, wish I could explain it better, but that's where we're at. So there are kind of two types of design components that we can use. There are logic components and there are sensory components. So logic components is the first one we're going to go over. Incentive. The incentive component has is immensely powerful and needs to be considered. One reason why is because having incentives can be used to reinforce the behaviors that you want, right? Through the player's behavior, the behavior that they're exuding is what's giving them emotion. The things that they're doing. So you need to be able to control that and get them to do the behaviors you want. For example, in Doom 2016, they use incentives to get the player to behave in a way that makes them feel like a badass, fast-paced warrior, dude. So other incentive components is the goal of the game, the fail states of the game, the negative consequences, which I define as any component that will get the user closer to an undesired system state, or another way of saying it is that it's any component that will get the player farther from their goal. Whereas a positive consequence is any component that will get the player closer to their goal. So content and level is another component. This is a curated mutation of the systems or system loops. So like we were talking about before with tools, mutation is any time when we change the rules or environment of the game. So that's when we think about levels. Levels and content are essentially just mutations of the core game, the core rule set. Yeah. Here's some more system. So a system is a design component that is composed of logic and sensory components. An input is anything that feeds into a system. It's our decisions, it's our interactions. Those are our inputs. Outputs. So these are the consequences of our decisions, the consequences of the inputs we do. Loop is another game design component. It's very important. So not every game is going to have every component in it, but this is a list of all the possible components you can use. It's a way of organizing and thinking about game design. So loops, you can have linear loops, non-linear loops, positive feedback loops, negative feedback loops, all different kinds. And these are all contextualized as different components. An object, this is an important component. It's very general. An object is anything that can have different types and categories, or anything that can be organized within a hierarchy. Think about in Doom or in chess. You know, you have types of pieces. You have types of opponents. Think about that opponent or piece as an object, and that there are different types of that object and different categories of that object within the game. A requirement is a game design component that is prevalent. It's any component of a system that cannot be accessed unless a requirement component is first met. And we have down here restriction and resource. Those components are pretty self-explanatory. Restriction is, you know, any component that restricts the player from doing some sort of action. Now with that build up, with that foundation, we can build up formal reasoning. We can construct sentences in our conversations that are very specific. We can say things like, in our critiques, we can say that, oh, I like your input components. I think if you added in a negative consequence component here, it would be a you know, a good incentive for the player. If you you know, made this loop a positive feedback loop instead of a, you know, or whatever, and also the decisions are game design components. A decision is a component, and there are different kinds of decision components. Oh, you know, maybe if you made this game maybe if you used simple decisions, simple long-term decisions, that would get you where you need to be, or you know. So we're able to use these terms and use this framework for thinking to build up more specific sentences, more specific arguments about game design. So that's really the point. So that's it. And that's all I have for philosophy and methodology. And eventually, once I complete my board game, which is the decisions about that game are being made over the framework of this methodology and philosophy. Well, if it proves to be, you know, a good way of thinking about games and it produces good games for me, then it'll have more legitimacy. But right now, it's really just a theory. So that's that. That's me and game design. So I hope everybody enjoyed it. I hope maybe you have some interesting things to think about. Check out Extra Credits on YouTube. Think about making design documents as flowcharts. I don't know. Take away what you will. For me personally, I hope I'm going down the right path. And yeah. So I'll see you guys later. I'll see you. I don't know how to end like a stream. Like do you just say goodbye? I guess I'll say goodbye, and I don't even know how to end this thing. Wait a minute. What do I do? God. I gotta take. Yeah. Well, hold up. Let's see. Hold on. If anybody's in the chat that like how do I close this thing? Stop streaming. Okay. I think this is gonna work, guys.